All right, so pre-calc challenge practice 4, I think is what this one is. I think. All right, so we got number one. Number one's going to be a factoring problem. We're going to shift everything to the left to set it equal to 0. And I was pretty tired when I made this problem, so I don't remember how it factors, but I think it's going to be I'm probably wrong about this. We're going to do 6x and x. Let's see here. If I put a 3 here, factors of 15 are 5 and 3, and a 5 there. The outside's going to make 18, and the inside's going to make 5. So that's what it is. We have a plus 3 and a minus 5. All right, so she's factored. Because 18x minus 5x is 13x. You know, Wood, I'm surprised you're not better at this because you're great with numbers. Like factoring should be your thing. All right, so we're going to use a ZPP. We're going to say 6x minus 5 is nothing, and we're going to say x plus 3 is nothing. We're going to add 5. 6x is 5. We're going to divide by 6. So x is 5, 6, because the opposite of multiplication is division. And the opposite of addition is subtraction, or the inverse. And x is negative 3. It's a bad looking negative 3, but it is what it is. Find the zeros of x to the fourth minus 81. It says factor one of the factors again, and then use ZPP. So I notice this is one of those special patterns in algebra. It's called an a squared minus b squared pattern. It's even on the ACT. Like, it's one of the things that say you should know how to do this. That factors is a minus b times a plus b. So this, if a squared lines up with x to the fourth, then a is x squared, because x squared squared is x to the fourth. Here we have an 81. B squared is 81, so b is 9. So we're going to have x to the second minus 9 and x to the second plus 9. Forgive my handwriting this morning. I'm not sure what's up with it. It's worse than usual. This is, again, the same pattern right here. It takes an x and an x to create x squared. Factors of 9 are 3 and 3. And to add to the understood 0x that's in the middle, they have to cancel each other out. This will never factor. There is no sum of two squares pattern. All right, so there we are. We're going to use the ZPP. So this one says x is 3. This one says x is negative 3. And this one is worth showing the work. Subtract 9 from both sides. The opposite of squaring is square rooting. Don't forget your plus or minus symbol. I know this is imaginary. Plus or minus thrice I. So there's your 4 zeros. It had 4 zeros by a fundamental theorem of algebra. Got ourselves a factoring by grouping. I notice that both pieces contain at least an x squared. And if I pull the x squared from x cubed, I have x. If I pull the x squared from 2x squared, I have 2. And with factoring by grouping, this piece is supposed to repeat. So in order to make a positive, I'm going to have to pull a negative. And I know that 288 divided by 144 happens to be 2. So I'm actually pulling out the negative 144. All right. I have a common factor of x plus 2, and the crap left over is x squared minus 144. Now, you're not done factoring this one. This is one of those a squared minus b squared patterns. Takes an x and an x to create x squared. 144 is going to be minus 12 and plus 12. And you have x plus 2 along for the ride. There's the complete factorization. Ta-da! All right, evaluate 1/64 to the negative 4/3. First thing that pops into my head is this x to the negative n rule. It's 1 over x to the n. And this works kind of funny. What we're saying here is we have a 1 to the negative 1 over 64 to the negative 1, and an exponent of 4/3. So think about it like that. You know, this just flips the fraction, because negative 1 times 4/3, by the way, is negative 4/3. Anywho, this makes this 64 over an understood 1 to the 4/3. And we don't need that 1. All right. Now what we're thinking is we're thinking about the cubic root of 64 that we turn around and we raise to the fourth power. So I know that the cubic root of 64 is 4, so now I have a 4 to the fourth, and I know that that's 256 because 4 times 4 times 4 times 4 is 256. Easy peasy, lemon squeezy. Find the solutions. You know, it's not this hard, but you must write two equations. Like that's the deal. It's not optional. M-U-S-T. Write two equations. That's what you do. The first one is as is. The second one, change these signs. And then you solve. We add 2. Negative 3x is less than or equal to 7. We divide by the negative 3. When you divide by a negative symbol, you flip the inequality. So negative 7/3 is one answer. I am greater than or equal to negative 7/3. Over here, I subtract 2 and I get 3, and I divide by 3 and I get 1. So a couple of you guys haven't been answering these right. Negative 7/3 would be about right here on a number line because negative 1, negative 2, negative 3, and then 1. Solid dots because I have equality. It says I'm greater than negative 7/3, which means I'm going to be headed this way. But this guy says, wait a second, you're less than or equal to negative 1. So I'm everything stuck in between negative 7/3 and 1. You know, it would look like this as an inequality or as an interval, negative 7/3, 1. Term the intervals on which this thing is negative. And the gist of these is to factor and graph. Well, by the way, being negative is being below the x-axis, but we're going to factor and we're going to graph. Let's try 5x and 2x. And we'd have what, 6 and 2, maybe? 3 and 4? Yeah, 3 and 4. The outside's going to make 20. The inside's going to make 6. And 20 minus 6 is 14 in the middle. All right, so now I'm going to think about the graphing here. Interesting that I chose something like that. I guess I could have pulled a 2 from everything, couldn't I? I don't know why I didn't do that. Must be early for me. This would say that x is negative 2. This one would say that x is 3/5. Subtract, divide, add, divide. I know that quadratics are the upward parabola, unless there's a negative symbol up front. All right, so negative 2 exists on the graph, so does 3/5. Then I have my parabola. Talk about negativity, and this is something that most of y'all are not doing on the quiz. You're not graphing. You're not doing it. Talk about being negative. That means I'm stuck between these two things. I am literally stuck between negative 2 and 3/5. Whereas an interval, negative 2 is a left boundary, 3/5 is the right boundary. And Milbrath is making a mistake. So let me erase all that. I don't need the equality symbols because there is no equality. If you touch these points, you're 0. Sorry about that. So there you go, negative 2 to 3/5. Use the decimal approximations of local maxima or minima to determine the intervals on which the function is decreasing. Decreasing is going downhill from left to right. So we're going to be decreasing from here to here. And from here to here. Downhill from left to right. So we talk about the x values. I'm coming in from negative infinity. I'm decreasing all the way until I hit this x value of negative 2.89213. All right, the next decreasing starts when x is 0.33851. This is something that most of you are not getting right, and it's like the easiest thing until x is 2.55362. I don't understand how you can be a senior in pre-calc and not understand domain. Like, I don't get it.